Everyone, in this video we are going to look at the derivations for the equations of motion. Now the equations of motion will be the equations relating the parameters of motion in case of the uniform acceleration. So here we will do the derivations for the equations of motion in general context, which means we are going to get the vector relations which can be used not only for the one dimension case but also for the two-dimensional motion as well as three-dimensional motion, provided the acceleration is constant or uniform. Okay, so just to give you the context of what are these equations of motion, if we have the acceleration constant, then we will call it as a uniform acceleration motion. In the case of uniform acceleration motion, we will have the parameters of motion, the initial velocity, okay, velocity, which we will generally represent by the symbol u. We are putting a bar because it is a vector. Then we have the time for the journey and final velocity. So what is this? V generally represents the final velocity, and acceleration and overall displacement. So S represents the overall displacement of the object during this journey time t. Okay, so we'll have relations between these parameters of motion, and that is what we call as the equations of motion. And one thing we need to be clear, that the equations of motion can be used only when the acceleration is constant. So we'll see how these equations of motion come. So just to make sure that we remember how many equations are there, we will just give them the number. It doesn't mean that okay, we have like first equation, second equation, third equation, we have to remember as such. These are not like the Newton's laws of motion where we'll have first law, second law, third law in a particular context. Here we are just giving the number so that we will remember how many equations are there in total. Okay, so the first equation, this is basically the equation that will come from the definition of the acceleration. It comes from the definition of the acceleration. Now remember, in case of uniform acceleration, the average acceleration value that you get between any two points of time in the journey, or the instantaneous acceleration value at any given point of time, both of them will be same, and of course that will be what? Constant throughout the journey. That is why we are calling it as the uniform acceleration motion. But how do we define the average acceleration? Will be equal to what? Final velocity minus initial velocity by the time. Now we'll just take the time to the left side. A bar into t will be equal to what? V bar minus u bar. We will bring the minus u bar to the left side. So u bar plus a bar into t is equal to v bar. We can also write it like this. V is equal to u plus at. One thing we need to keep in mind is that here v, u and a are what? Vectors. Okay, so that is the reason why we said, we are going to derive the relations in the generic form or the vector form. These equations can be used not only for the 1D motion but can be used for the 2D or 3D context also. Okay, later we will see how we are going to modify the equations, particularly in the case of the one dimension case. Okay, so this is the first equation of motion, which is straight away coming from the definition of the acceleration. We'll move on to the second equation of motion. This is also called as the displacement equation. So what is this second one called as displacement equation? So I mean, from the name itself, right, from this equation we are going to get the formula or the expression for the overall journey displacement. So if you consider the expression for the instantaneous velocity at any given time, what is the instantaneous velocity? The small displacement that happens in a time interval dt. So dt is what? The differential time interval. So you might have to check the basic math videos once again before we look at these derivations, because we are going to use the concepts of integration. So here ds represents what? The displacement in dt time. Okay, so the small displacement by the time taken will give us what? The instantaneous velocity. So if you start your journey with a initial velocity u, and we are at time t, which is any general value for the time. So we are at a time t, which is any general value for the time. Okay, then what is the final velocity formula already we have got it from the first equation. What is the final velocity formula? U plus A into T. Final velocity means the instantaneous velocity at time t. Okay, that is equal to what? ds by dt. Now we will bring the dt to the left side. So u plus a into t dt will be equal to what? ds. ds is basically the small displacement that is happening in that dt time. Okay, now if we integrate this here, left side, what is the integration variable? It is the time. So our journey is starting from 0. Let us say it is concluding at time t. So we have to integrate the time from where to where? 0 to t. So if you integrate the left side within the limits of 0 to t, on the right side, right, it is like what? Integration of ds means we are adding up all these small displacement values. Integration is what? Summation, right? We are adding up all these displacement values. That is going to give us what? The overall displacement in this interval. What is the interval we are looking at? 0 to t time interval. So this integration is going to give us what? The total displacement in the time interval from 0 to t. That is what we are calling as the displacement in that time t. Okay, now our task is to simplify this left hand side expression. So right hand side is giving us what? The total displacement. So let us shift. We'll express the RHS onto the LHS because that is how we want to write the final formula. We will keep this LHS part to the RHS side. So integral 0 to t u bar plus a bar into t dt. Okay, so here we will split the integration. So integral 0 to t u bar into dt. This is a property of the integration. If you have integral of a plus b, that can be written as what? Integral a plus integral b, like that. Okay, a bar into t dt. Now here since u is the initial velocity, that is a constant, it will come out of the integration. What we have? Integral 0 to t dt. There a bar is a constant because if the acceleration is constant, you are talking about what? Uniform. We are talking about the uniform acceleration motion. So a bar is constant. What we will have? Integral 0 to t dt. Okay, so here I'll just erase some part of the left side. We will have to quickly recall what are some of the basic integration values. What is integral dx? I mean, here generally when we learn the integration, right, we will be using the variable as x, but of course here what is the variable? T is the variable. Okay, so quickly to remind, integral dx will be equal to what? X. Limits are there means, let's say limits are what? Xi and xf. So we have to substitute the limits. Means what is it going to be? Final limit value of the x minus initial limit value x. Integral initial limit to final limit x dx, like that it is there. Then what is it going to be? X square by 2. Again we have to substitute the limits, which is what? The final limit value minus initial limit value. So this is how we'll have the simple integrations. We have covered them in the basic math videos. Now as such, integral 0 to t dt, so it's like what? The final limit time is what? T minus initial limit of time is what? 0. So we'll get what? U bar into t minus 0 will come here. Just as such, replace x with what? T, that's it, plus a bar into, so here it is like what? X dx. T dt is like what? X dx, right? So what is the result? We are going to get x square by 2, means here we'll get t square by 2, but we have to substitute final limit minus initial limit, means what? Final limit is what? T. Initial limit is what? 0. So t square by 2 minus 0 square by 2. Just look at how these integration results are coming. Now we got our answer. What is it? This is t minus 0 is what? T only. No. So u into t plus this is 0 square means what? 0. So we are having half a into t square. This is what? The overall displacement of the journey in time t. So this is our second equation of motion. This is for what? The displacement. Okay. So here one thing we need to tell, here we are doing the derivations by using the numerical approach. There is also one more method of doing the derivations, that is by using the graphical approach. Okay, we'll discuss about getting these equations of motion using graphical approach when we go and look at the graph analysis. The motion of an object can be studied also with the help of the graph. Graph means what? we'll have x-axis as time, and maybe y-axis we can represent a velocity value or displacement value or acceleration value. We can have a lot of different types of graphs. From the graphical analysis also, right, we can do these derivations that we'll cover when we go to the graphs. Okay, but here this is the approach numerically by using the integration method. So we get our second equation. What is it? S is equal to what? Ut plus half at square. Here why are we putting bar for them? Because S, U, A, they are what? Vector quantities. Time is anyway scalar. Now we'll come to the third equation. So the third equation, right, this is in a way a merging of the first and second equations. So we'll see how we are going to get the third equation. So here third equation is more of a mathematical simplification. Okay, so we'll try to get what is this third equation. So if you do dot product of final velocity with itself, v dot v, because vectors can be multiplied in two ways, right, either dot product or cross product. So here in place of v, we will replace this with what? U plus at. In place of another v also, we will replace this with what? U plus at. Now we have to apply the distributive law. So here first term, then we have the second term. Here this is the first term, this is second term. So first what we will do? Take the u, do a dot product with the first term here, second term there. Take that at, do a dot product like that. So look at it. So first we will have what? U dot u. So u dot u plus u dot at. Then we will take at. Okay, so at dot u plus at dot at. So here we'll have it as u dot u. So here if you see the u dot at dot u, because we have a property of the dot product, a dot b will be equal to what? B dot a. Means both of them are giving us the same value. So we will write it as what? 2 times at dot u. Okay, so t is a scalar, we have to keep that in mind. Okay, plus here what is it? A dot a into t square. So here also we can just take the t out because it is after all a scalar quantity. So we'll have what? 2a dot u into t. So we'll keep the scalar numbers 2 and t separate. So what is it? A dot a into the t square. Now we have property of the dot product. Like say for example, if you have a dot b plus c, it can be written as what? Distributive law. A dot b plus a dot c. Reverse, if you have a dot b plus a dot c, we can also write it as what? We can take out the a common and we can write it as what? A dot b plus c. So here we see a dot is here, a dot is here. Okay, so we can take it out and then by using the distributive law, but we are using it in the reverse manner. That's it. We are using the distributive law in the reverse manner. So look at it, what we are going to get. We will be getting, what are we going to get? So the first term will be as it is, nothing is changing to this. U dot u will be as it is. So we will get the a dot out. So inside what we will have? 2u into t plus, what is this? A dot has come out, a dot into the t square. Now do we get reminded of self of something? What is this? We have s is equal to what? Ut plus half at square. Means what is this actually? This is the 2s. So look at it, u dot u plus a dot 2s. We can also write it as what? U dot u plus 2 times. We'll just take that 2 separate because it is a scalar constant. Okay, so what is the final equation we have? V dot v will be equal to what? Maybe I'll just write it with a different marker so that we can clearly see. So this equation, right, is more of a mathematical merging of equation 1 and equation 2. So what are we having finally? V dot v will be equal to what? U dot u plus 2a dot s. Okay, so here because we are dealing with the vector notation, right, we are having the dot product. When we simplify this equation for the one dimension motion, right, we will see that the dot product in that case will not be existing. We'll see when we go to the simplification of the equation for one dimension motion, we will be able to understand, okay, how that simplified form will be looking like in the case of the one dimension. But this is the general vector equation. V dot v is equal to what? U dot u plus 2a dot s. Now in the uniform acceleration case, the velocity will be changing. So how the velocity will be changing? If you start your journey with a velocity u and we are ending up with a final velocity v at the end of the journey during a time t, we can also talk about what will be the average velocity of the journey. What is the average velocity formula? So normally what is the average velocity formula? It will be what? Total displacement by the time taken. What is the total displacement? Already we have a formula, right? What is it? Ut plus half at square. That is the total displacement. Divide by t. Means you see ut will split the denominator. Okay, so plus half a t square by t. So we can see t here is cancelled. Here 1t. So what is the average velocity? It will be what? U plus half a into t. What is this? U plus half a into t. So we will take an LCM here. So 2u plus at by 2. Now we will just write the 2u separately as u plus u. You will know why we are writing it. So we are just trying to simplify it. Okay. So here when we write it as u plus u, you can observe one thing. What is the second term? U plus at. What is u plus at? V, right? In the journey, what is the final velocity formula? That is the first equation of motion. V is equal to what? U plus at. So look at it. What is the final formula? U plus v by 2. So this is the average velocity of the journey. So during this uniform acceleration motion, if between two time values we want to find what is the average velocity, right? That will be simply nothing but initial velocity u plus final velocity divided by the 2. Okay, so we have to keep one thing in mind, that all these equations of motion are in which case? They are in the case of the uniform acceleration. Okay, now we have one more important formula here, that is what we call as the displacement in the nth second. What do you mean by the displacement in the nth second? See, we are starting our journey from t is equal to 0. The displacement formula, right? What is it? Ut plus half at square. You know what this is? This is the displacement in the entire journey time of t. This is the displacement in the entire journey time of t. Okay, so here we are talking about something different. Displacement in the nth second of the journey. So what are we talking about? Displacement in the nth second of the journey. What do you mean by this nth second? See, when you start the journey at t is equal to 1, t is equal to 0, the t is equal to 0 to t is equal to 1, this interval is actually called as what? The first second of the journey. T is equal to 1 to t is equal to 2, that is called as what? The second. T is equal to 2 to t is equal to 3 seconds, that is what? The third second of the journey. You know what is the nth second means? It will be what? T is equal to n minus 1 to t is equal to n. This interval is what we call as the nth second. So t is equal to 0 to t is equal to 1 is what? First second of journey. T is equal to 1 to t is equal to is what? Second. Nth second like that means what? T is equal to n minus 1 to t is equal to n. So here what we have is the total displacement formula. Means, look at it, no. We can find what is the total displacement in n seconds. If you put in this formula p is equal to n, what we are going to get? Total displacement in the n seconds. Let us call it as what? S within bracket n. In the same formula, if we substitute t is equal to n minus 1, what we are going to get? The total displacement in the n minus 1 seconds. Remember, what we are looking for is this value. What is this? The displacement in the nth second. Like we can say S subscript n. Okay, so instead of putting the bracket, right, what do we say? S subscript n. So here we'll put the n as an subscript. Okay, so this is what we are calling as the displacement in the nth second of the journey. By now itself you would have understood. How are we going to get it? How are we going to get this value? This value is going to be nothing but total displacement in n seconds, that we are going to get by putting t is equal to what? N, minus from that we have to subtract the displacement in n minus 1 seconds. Means what? Same formula, we will put t is equal to n minus 1. So we are going to do the derivation now. So we are going to find out what is the displacement in the nth second. First we need to understand what do you mean by this nth second of the journey. Nth second of the journey means what? That time interval from t is equal to n minus 1 to t is equal to n. Okay, so how are we going to get it? In that total displacement formula, we will find out what is the displacement in overall n seconds. That is what? un plus half a n square. From this we have to subtract. From this, what we have to subtract? Displacement in n minus 1 seconds. Means u into n minus 1 plus half a into n minus 1 the square. So from this we have to subtract displacement in the n minus 1 seconds. This is what is going to give us s subscript n. Okay, so that is what we are calling as the displacement in the nth second. Now it is more of mathematical simplification. So look at it. What is it? un plus half a n square. Here now we'll have a minus. First we'll try to simplify what is there inside the bracket. un minus u plus half a into n minus 1 whole square means what? N square plus 1 minus 2n. Okay, so un plus half a n square. Okay, then we'll have, first we'll try to simplify everything inside the bracket. So this is what? Half a n square plus half a minus a into n. So we are simply multiplying. So half a with n square, half a with 1, half a with minus 2n. Okay, so we multiplied it. Now we will open up the brackets. When you open up the bracket, what is going to happen? You see, this is what? This will become minus un. Already there is a un. So I'll use a different marker so that we can see what terms are getting cancelled. So here you will get what? Minus un will come. There is a un. They will get cancelled. Half a n square is there. You are going to get, there is a minus outside. We are going to get minus half a n square. This also will be cancelled. So let us write down the remaining thing. Minus into minus becomes what? Plus. Okay. Then minus into half a will become what? Minus half a. Minus into minus an will become what? Plus an. Okay. So look at it. U. We will take out a common out. So if you take out a common, then what we'll have inside the bracket? We'll have n minus half. So what is this? Sn. That's what we call it as. This is the common notation. Sn means what? The displacement in the nth second of the journey. What is the formula for this? U plus a into n minus half. What is it? U plus a into n minus half. Okay. So we can also write it by taking an LCM. So in some textbooks they will write it like that also. Okay. So either we remember it like this or you take an LCM. Here what you are going to get? U plus a, take an LCM means it will be what? 2n minus 1 whole divided by 2. Okay, so what is it? U plus a by 2 into 2n minus 1. Like that also we can remember. Okay, so either we'll remember it like this, u plus a into n minus half. Otherwise we can take that LCM inside the bracket and then write it as what? 2n minus 1 by 2. Okay, so this is what? This is the displacement in the nth second of the journey. So these are all the relations we have between the parameters of the journey, and that's what we call as the equations of motion in the case of uniform acceleration. Now as we have seen, these relations are in which form? They are in the vector form. So we'll see how we can simplify these expressions particularly for the case of the one-dimensional motion. There we'll use the concept of something called as sign convention. Okay, so we'll learn about it in the next video.